poured into the unlimited and perpetual drain of the universe, the James Webb Space Telescope, JWST, has been looking into the profound lack of definition, endeavoring to unlock the secrets of the universe. This cutting-edge instrument, a coordinated effort by NASA, has been uncovering stunning pictures of far-off stars, huge cosmic structures, and planets. However, as of late, an absolutely shocking revelation has come to light, one so momentous that it could potentially shake the very foundation of how we understand existence. This finding has left researchers in awe, pushing them to examine whether it could mark the ultimate limit of the physical universe. Join us as we explore the latest breakthrough from the JWST and examine how it could challenge the very essence of the universe's structure. When we look at the edges of the universe, we are seeing the observable universe, which represents just a small fraction of the entire infinite expanse. This observable fragment is our limited perspective, a small slice of the universe that allows us to detect and study the parts we can currently measure and explore through telescopes and experiments. It includes an assortment of stars, galaxies, and other celestial bodies within our current scientific understanding. However, the observable universe is just a minute portion of the whole universe. Consider it a small slice of a massive cosmic pie that we can observe and learn about, even though the full shape and size of the universe remain unknown. Estimates suggest that the observable universe spans over 93 billion light-years in all directions. To appreciate just how vast this is, one must understand what a light-year represents. The distance that light, the fastest thing in the universe, travels in 1 year, around 5.88 trillion miles, roughly 9.46 trillion kilometers. So, when we say the observable universe spans 93 billion light-years, we are referring to a truly staggering distance. Around 13.8 billion years ago, the universe began with a remarkable event, the Big Bang. This tremendous explosion marked the birth of everything, setting the universe on a path of rapid expansion. Since that moment, the universe has not just been expanding. It has been evolving, driven by mysterious forces like dark energy. This unseen force continues to push the outer reaches of the universe farther and farther apart. As the universe expanded, gravity acted to organize particles, leading to the formation of stars, galaxies, and planets, including Earth. Imagine the universe unfolding, with these colossal structures developing into the vast and still evolving wonders we observe scattered throughout space. Despite its immensity, the universe is astonishingly empty. If we were to shrink our solar system to the size of a quarter, the nearest star would still be as far away as 2 soccer fields laid end to end. This vast emptiness is evident even within our own Milky Way galaxy, which is just one of billions of galaxies in the observable universe. This gives us a striking sense of just how truly extensive and incomprehensible space is. You might be wondering why we cannot see everything that exists in the universe. The reasons are complex, but a significant one is the speed of light. While light is the fastest known entity in the universe, it still takes time to travel through space. This means that when we look at distant objects, we are essentially seeing their past. The farther away an object is, the longer its light has taken to reach us, so we observe it as it was long ago. It is like looking through a giant time machine, watching the history of the universe unfold. When we view galaxies millions or even billions of light-years away, we are not seeing them as they are today but as they were eons ago. As the universe continues to expand, the very fabric of space stretches, causing galaxies that are farther away to drift even farther apart. This expansion creates a phenomenon called redshift, in which the light from these distant galaxies shifts toward longer wavelengths, often taking on a red hue. This stretching of light, coupled with the vast distances of space and the ongoing expansion of the universe, helps explain why we have not yet observed the entire cosmos, even with our most advanced telescopes and technology. The quest to understand the ultimate boundaries of the universe has captivated scientists, philosophers, and visionaries for centuries. While definitive answers remain elusive, 3 major theories have emerged, each offering a distinct perspective on the true nature of the cosmos. The first theory suggests that the universe is infinite with no discernible edge, aligning with the cosmological principle that proposes the universe appears the same from every perspective. If this idea holds, then the universe has no true boundary and extends endlessly in all directions. The second theory presents a different idea, proposing that the universe is finite but without a clear boundary. It could be curved, much like the surface of Earth. In this case, if someone were to travel endlessly in any direction, they would eventually return to where they started, akin to circumnavigating the planet. The third theory, the multiverse hypothesis, introduces an even more intriguing concept, that our universe may be just one of many. Imagine an infinite number of parallel universes, each with its own set of physical laws and constants. These universes could exist independently or be interconnected in complex ways, forming a vast multiverse. The James Webb Space Telescope is a beacon of possibility, an instrument capable of uncovering profound insights about the origins of the universe. This remarkable device enables us to peer back in time further than ever before. A groundbreaking report, recently published in the esteemed journal Nature, revealed that the JWST has detected 6 massive galaxies that existed a mere 500 million to 700 million years after the Big Bang. These galaxies, surprisingly enormous for their early age, challenge previous theories about galaxy formation. What is truly extraordinary is how developed these galaxies are. They contradict the prior belief that galaxies gradually evolved over time. These massive giants exhibit an astonishing level of refinement, similar to our Milky Way galaxy, which is over 13 billion years old. Each of these galaxies contains far more stars than expected, with some having masses up to 100 billion times that of our Sun, surpassing even the size of the Milky Way. This discovery is made possible by the JWST's ability to detect infrared light, which is invisible to the naked eye. This exceptional capability allows the telescope to identify faint emissions from distant stars and galaxies, revealing ancient remnants that have existed for billions of years. In essence, the JWST acts as a time machine, offering us a glimpse into how the universe appeared approximately 13.5 billion years ago. The discovery of these giant galaxies, often referred to as galaxy breakers, has forced scientists to reconsider how galaxies form. Previously, researchers believed that galaxies formed gradually from small clusters of gas and dust. However, these massive structures seem to have emerged suddenly, as if they had been waiting for us to find them. This new understanding is prompting researchers to rethink the timeline and mechanisms behind galaxy formation. To investigate these newly discovered cosmic giants, scientists have used spectroscopic techniques to analyze the light emitted by these galaxies. This research is crucial for uncovering details about their size, structure, and distance from Earth. With each new revelation, we are reminded of how much more there is to learn. The possibility that the observable universe is merely a small fraction of a vast multiverse is an intriguing prospect. If this theory is true, our universe is just one of countless others, each with its own distinct physical laws and constants. As space exploration advances and the JWST continues to push the boundaries of our knowledge, we may soon uncover even more groundbreaking discoveries that reshape our understanding of time, space, and existence itself. The implications of these discoveries extend far beyond the scientific community. If the universe is truly infinite or part of a multiverse, then the very nature of reality itself must be reconsidered. Questions once relegated to the realm of philosophy now demand rigorous scientific inquiry. Are there alternate versions of ourselves living in parallel universes? Could different physical laws govern these unseen realms? The James Webb Space Telescope has opened a new frontier, one that challenges our deepest assumptions about existence. Another significant aspect of the JWST's findings involves the search for habitable exoplanets. By analyzing the atmospheres of distant worlds, scientists can determine whether these planets possess conditions conducive to life. This revolutionary capability brings us closer than ever to answering the age-old question: are we alone in the universe? One particularly promising target is the TRAPPIST-1 system, a collection of 7 Earth-sized planets orbiting a red dwarf star approximately 40 light-years away. The JWST has already begun observing these exoplanets, searching for biosignatures, chemical indicators of life such as oxygen, methane, and water vapor. If such signs are detected, it could represent the most profound discovery in human history. Beyond the search for life, The JWST is also shedding light on the mysterious nature of dark matter and dark energy. Dark matter, an invisible substance that makes up roughly 27% of the universe, continues to elude direct detection. Meanwhile, dark energy, the force responsible for the accelerating expansion of the universe, comprises nearly 68% of the cosmos. Understanding these enigmatic components is crucial for developing a complete model of the universe's structure and fate. As the JWST continues its mission, the data it collects will refine our theories about cosmic evolution. Each new image and spectrum provides a glimpse into the past, allowing scientists to piece together the grand puzzle of existence. The discoveries made today will shape the questions of tomorrow, ensuring that humanity's quest for knowledge never ceases. Ultimately, the JWST's findings reaffirm a humbling truth. The universe is vast, mysterious, and far beyond our full comprehension. Yet, with each technological breakthrough, we edge closer to unveiling its secrets. Whether we discover the limits of the cosmos or prove that it is boundless, the journey itself is as awe-inspiring as the destination. The James Webb Space Telescope is not just a scientific instrument. It is a testament to human curiosity and our relentless pursuit of understanding the infinite. In any case, this revelation, in addition to more than a dozen extra competitors, is a big part of universe web information that still can't seem to be portrayed in the logical writing. This suggests they may be 3 to multiple times as normal true to form. Jed McKinney, a postdoctoral specialist at the College of Texas at Austin, said, "This thing is a genuine beast. Despite the fact that it seems to be a little mass, it's in reality forming many new stars consistently. The fact that even something that extreme is scarcely noticeable in the most delicate imaging from our freshest telescope is so invigorating to me. It's possibly letting us know there's an entire populace of worlds that have been stowing away from us. Assuming that end is affirmed, it could mean the early universe was a lot dustier than recently thought." The group distributed its discoveries in the Astrophysical Journal. For pictures of a similar piece of the sky in various frequencies of light, show the picture on the extreme right addressing a world. The picture on the extreme left gives no indication of this cosmic system. The cosmic system Aztec 71 is clearly visible in the reddest variety channel of the NIRCam instrument on the James Webb Space Telescope. However, it is not at all visible in the bluest channels. The Universe Web Project, the biggest initial JWST research drive, is co-led by Caitlin Casey, a professor at UT. It aims to map up to 1 million cosmic systems from a piece of the sky the size of 3 full moons. The objective, to some extent, is to study the earliest structures of the universe. The team of over 50 specialists was awarded 250 hours of observing time during the James Webb Space Telescope's first year and received a first batch of data in December 2022, with more coming through February 2024. A dusty, star-forming world is difficult to see in optical light since much of the light from its stars is absorbed by a shroud of dust and then re-emitted at redder or longer wavelengths. Before JWST, astronomers sometimes referred to them as Hubble-dim galaxies, referring to the previously most sensitive space telescope. Up to this point, the main way we've had the option to see worlds in the early universe is according to an optical point of view with Hubble, McKinney said. That implies our comprehension of the historical backdrop of universe advancement is one-sided on the grounds that we're in particular seeing the unobscured, less dusty cosmic systems. This world, Aztec 71, was first identified as an indistinguishable mass of dust emission by a camera on the James Clerk Maxwell Telescope in Hawaii, which observes frequencies between the far infrared and microwave. The Universe Web Group quickly detected the object in data gathered by another team using the ALMA telescope in Chile, which has higher spatial resolution and can see in infrared. This allowed them to narrow down the location of the source. When they searched in the web data at a wavelength of 4.44 microns, they found a faint galaxy in the exact same spot. However, in shorter wavelengths of light below 2.7 microns, it was invisible. Now, the group is working to uncover more of these faint galaxies using the James Webb Space Telescope. McKinney said, "With Webb we can, for the first time, study the optical and infrared properties of this heavily dust-clouded, hidden population of worlds. Since it's so sensitive, not only can it gaze back into the farthest reaches of the universe, but it can also pierce through the thickest of dusty covers. The team estimates that the galaxy is being observed at a redshift of around 6, which means it existed approximately 900 million years after the Big Bang. Now equipped with the incredible James Webb Space Telescope, researchers recently discovered 6 new galaxies, but these galaxies shouldn't exist, at least not according to our current understanding of the universe. The telescope detected these cosmic anomalies only 300 million years after the Big Bang. So, what are these strange galaxies, and how did they manage to evade our grasp for so long? These newfound galaxies have been fittingly named universe breakers by scientists, signaling a challenge to established cosmological theories. They emerged from the cosmic dawn, between 500 to 700 million years after the Big Bang, contradicting our expectations of finding small, young, and blue galaxies. So, how did the James Webb Space Telescope make these groundbreaking discoveries? It all comes down to the telescope's exceptional capabilities. Its ability to peer into the infrared spectrum allows it to see through cosmic dust clouds that would otherwise obscure our vision. This means it can observe objects that emit faint infrared light, revealing celestial wonders that were previously hidden from view. However, the universe breakers defy this assumption, revealing a universe where massive galaxies, similar to our own Milky Way, existed far earlier than expected.